Hey, welcome back to another video. This week we're working with SwiftUI. We're gonna make some custom adjustment to SwiftUI that allow us to have access to like content offsets. So in front of me is a final product. I have from 0 to 50 item. As I'm scrolling, you see this number is changing. That's just how much we scroll, like basically the offset from the top. So I'm going to show you how to make that today. This opened up a lot more possibility in terms of animation. For example, if you have like some sort of header here, and when you scroll, you want your username to be up here. You can also do that, right? And then when you scroll back down, you want this to disappear and disappear, and you can do that with like the custom offset SwiftUI. So let's not waste any more time and let's. Alright, so we can start. In front of me, just an empty SwiftUI project. We're gonna start with making our SwiftUI. Let's call them track SwiftUI, right? We're also taking in content where content gonna be a view, and our thing gonna be view. Right? And let me scroll down. So we SwiftUI typically have the few variable. Let's first is axis dot set, and then let show indicators. There's also a bool, and let's say what are we missing? We're missing content. That's where our main content gonna go, and then we introduce a new variable called offset, and this gonna be a CG float. Alright, and hang tight. I'm gonna make our initializer. Alright, so now we have our initializer. Let's make our body, and here I'm gonna start with a geometry, not proxy, it's called geometry reader, and I will name this our reader. And I'm gonna also do a scope. I'll explain why we name it our reader later. We're gonna do cell. We're gonna use axis, and we're gonna do cell dot show indicator. We'll do that, right? And then we put a z stack with alignment the top. I want to do a top here, and I'm going to do another geometry reader, and I'm going to call this in reader. I can't spell. Let's say color. We're going to do a color dot clear, and then we have a v stack of, let's say, cell dot content. This doesn't need to be 3 line. It's a view code line. Let's see. Okay, so the reason we have an outer reader and the inner reader is that we want to create 2 frame. So the outer reader will be a bigger frame and the inner reader will be a smaller frame, and we're gonna find the difference between them. And the reason I'm using Z stack is that I need something to act as a frame holder kind of way. So this is a trick using color clear, so the user doesn't see anything, but underlying we will be working with this, right? We will not be touching anything with this at all. So with that, we're gonna start with making our struct of, let's call it SwiftUI preference key. I hope I spelled right. We're gonna have a type alias of value. This is gonna be an array of CG float. All right, let's take this out. And preference key always require you to have some sort of default value. So we're gonna have default of 0. Then we have the last function called reduce, and we basically just gonna value dot append, and we need to use this one, the append content op instead of new element, because new element only allows you to append CG float. This allows you to append a sequence outside. As you see, if you look at the next value, it's an array of CG float, right? So that is a sequence. So when we do next value, now that should work, right? If you delete this, you see an error. So no worry, you won't be mistaking it. And here we have our preference key, what is called a preference key, and our SwiftUI preference key dot cell, that's a type, And this here, the value, that's where we calculating our offset. But there's no reason to calculate here. It's gonna make a messy code, so we're gonna extract into another function. Let's call them handle calculate offset, right? And we need two parameters here. We need an outer proxy, and this in the geometry proxies, and we need inner proxies. Geometry proxies, and this we gonna be return an array of CG float. All right. If we recall, if we look at this is preference key value, and we know that our preference key, and we know our value is an array of CG float, so we must be the return type must be a CG float. Let's see. Here we're gonna be return an array, so we're gonna say outer proxies. We're gonna do frame dot global. We're gonna do a min y minus same thing in the proxies dot frame dot global dot min y. Alright, now that we're gonna call cell dot handle calculation knobs the proxy. We're gonna do outer reader and in reader. Alright, so now we have our preference key calculated. We basically have offset calculated. What we need to do next is update it, right? And we say on preference key change on the second one, where we say scroll dot cell again, and here is where we handling our change, and this value typically should be an array of CG float. So we're going to do cell dot let's say offset equal to value 0. All right, we don't have to worry about checking like if their first element exists or anything like that. We just have to get the first element because there's a default value, right? And anything if the preference key fail, it's always go back to default value. So we know that we always have like at least one element in there. So your worst case offset is going to be equal to 0. So we no need to worry about that. With that, we should have is ready. So let's go back up here to our parent view. I'm gonna do a vstack, and I'm gonna do before that we need to make our stay private with our we call them offset and CG float might be 0, something like that. Let's say this my pass, so we do that. Let's offset, right? I think you might need to do a cell, but maybe though. And let's call out new scope view, track scope view. If it's a vertical, we don't do any of this, right? I'm just gonna leave everything is the same. We'll do an offset of offset and content slide demo. I'm gonna do a for each of 0 to 50. This is the easiest way to show. Let's do a text of that. I'm gonna pass in, nope, not 90. With that, it shouldn't work. Let's run it, and that's over here. All right, here if I scroll, you see this value changing. Now that's pretty much it. If you want just one for vertical, but we're gonna adapt this a bit further to make it like compatible for horizontal as well. Let's see, we going down here, we don't need to do anything here at all. This is where we calculate the thing. So calculate our offset. I don't know why I say thing. Let's say cell dot axis equal to vertical. We know this is a vertical calculation, right? You're gonna do an question mark here. We can do, you know what? We don't need to retype everything. We just copy it here and we paste it. All right. So instead of min y, we do min x. Min x. All right, that's, yep. And let's go up here. We want to change our alignment because this, if you have a vertical, of course your alignment will be on top, but we have horizontal. Then we have our alignment like in leading instead. Let's see, dot leading axis. That's not all vertical. If it's vertical, do top, else I'll do a leading. Okay. And lastly, we need to do this. If cell dot axis, wow, axis equal to vertical. All right, we're gonna cut this and paste this here. And else we can do H stack on this instead, and do cell dot content. Right. Because H stack, when you put everything, you want to put everything in an H stack. There's no reason to leave it V stack. With that, let's see. Yeah, let's run again. Now we're gonna do a horizontal instead. Let's see what's the new scope reduction work with H stack. Ah, there you go. Now you have an H stack working as well, and you can score what you want. Let's see. The reason, a bit more explanation. The reason we don't want to use max Y in here or max X is that because if you're using, for example, if you have a vertical view, max X is gonna put the bottom at 0 instead of the top, and same thing for horizontal. We'll put like all the way to the end at 0 instead of top. That wouldn't result in what we want. That's pretty much it. If this video helped you out, please give a like and subscribe. Thank you so much for watching, and I hope to see you guys next week.